Hello, hello. All right. Time to continue onwards. We want to implement some more debugging stuff. We want to be able to draw some points. Um, we already support line drawing. And we want to be able to debug our contact manifolds for our physics system. In order to be able to draw points, we need a new pipeline for our renderer. And let's see how our data is already organized. So right now we have polygons, lines, and then we want some point billboards. We want to create the pipeline inside our renderer. Let's just collapse these for now. We have our create bounding volume buffers. We don't need that. But inside our initialization method, we want to create another pipeline. We want to let's see, create the polygon pipeline. Create the line pipeline, and then we want to create the point billboard pipeline. And it will billboard point billboards PSO. And we set the name of the root signature. And then we create a new folder in our shaders, which will be called point BB. And we will do point BB. And we will have to calculate our mask. Right now this will crash. Unless we set it to 0, I think. This will be fine. Oh well, nope. We still need to create some shaders. I'll simply copy some shaders over. Start out with some base shaders. Or rather, just copy from the lines shaders, since They won't be that different, I think. Let's see. All right. Get blob, build shaders. Yeah, of course. It right now doesn't work if let's see, did we create somewhere a layout for this? No, we didn't. Okay, let's just initialize it with 17. Let's see, calculator, programmer, decimal number, 17. So the 3 in between. DirectX graphics pipeline. Let's see, what will be our? We will have a geometry shader, I think. Usually that's what I use for creating billboards. Yeah, it's the geometry shader, and it's the uh, second to last one bit shifted by 3, I think. Right? Yeah. So that's 25. That's our bit mask. And the 3D12 point. Great stuff, great stuff. And inside our pipeline build shader function, we want to add the case 3, our geometry shader. Let's see, shader type, geometry shader. And we of course need to add a geometry shader. All right. And we want our out target to be, I think it's GS. Yeah, it started to recognize that we're trying to load up a geometry shader. Great stuff. I'll just add the actual file. We copy this. And then tell it that we want a geometry shader for that. Loaded shader. All right, and then we want to create a geometry shader. I have an old one which do billboards. Which does, sorry for my bad grammar. All right, we have one here. So this is an old geometry shader that I previously used. So we can simply use a bit of this. Let's refresh everything inside this. We will probably change up some stuff. Let's see. Yeah. New vertex shader output. We don't need this. We don't need this. And let's just do a void function that doesn't return anything. And as you can see, we do create a struct called geometry out. We don't need the text coordinate, but we want the float for. Let's see, let's organize it this way. Float for. Color. Color. We're not going to use textures for this one. I'll just move this off screen. Now you've seen it. Max vertex count 4. Maybe we actually do need some past data. Maybe we actually do need that. All right, then we create the coordinate system. Let's see, do we actually pass in our base one here? Inner vertex shader. Object data. Inner pixel shader. Maybe in our shared pass data. Yeah, we do pass in the pass data. We can comment out this and perhaps comment out this. So let's see, we create the basis. We want to create the four corners. We want to make sure that this is a sort of billboard square that we create. So we want a point as our input. I'm not sure. This is probably our output. I'm not sure. Maybe we do want clip space. No, we don't want that actually. We only want the world position and then the color. This is going to be with a hard-coded size. Since it's points and it's billboards for points. Yeah, but we want the billboard to be oriented towards the camera. Let's see. We take in a point array of 1. And we create an up vector by simply hard coding the up vector. Then we do the looking direction, which is also a vector. Free. There we go. And we calculate that from the vector from the camera position to the input. Let's see. This is probably going to work, but let's see. We do the pass constant buffer data, camera position minus our input. Do we actually need that? I'm not sure. Input dot position, and then we set the look y-axis to 0. Since we only want it along a forward-going direction, then we normalize. I love how math functions are just built in HLSL. And then we, of course, create the right vector by crossing the up and the looking direction. Now we have our basis vectors. Next, we want to define some half width, and we want some half height, which is equal to the half width because we're doing basic squares. We want to create a series of vertices that are possible to transform. We want our 4 vertices. We will fill in the information. We will take our input, center positioning, and add the half width times the right vector, and we will add the half height by doing it like this times the up vector, and then we add in the last component. By doing like this, we are able to change if we want something more rectangular. But we could just do simple squares. This will be the minus, and the last 2 vertices will be one where we minus and minus, and one where we only minus and plus. This will create our 4 corners of our billboard. Next, we're gonna do an unrolled loop where we not faithful. Do god damn it! Please do not change my for loop. And we create our geo out. Didn't I create a geo out? Yeah, I did. Output. IntelliSense just being slow. And let's see our multiplication order here. Yeah. So we take our output and set the position in terms of I'm not sure it should be called H. I could maybe it's in yeah, I think it's in homogeneous clip space. Anyway, that is why we call it H. And then we take the view projection matrix, and we of course multiply the vertex first. Great stuff. We store our local position, which is simply just the vertex position in object space. And we store our primitive ID as a primitive ID. In geometry shaders, you simply specify some arguments where you kind of assign your primitive ID like this, and you do an in-out stream of a triangle stream of the geo out information. This means that it creates a lot of, or rather, it creates the faces for these vertices. You specify the arguments like that, and then now you can assign the primitive ID, and you can simply tell the, as you can see, you can add the geometry data for each of your vertices. So we calculated our output here. So this basically takes one input point and creates a maximum of 4 vertices and stores it in a triangle stream, meaning that all 4 vertices will be arranged like vertices in a face. All right, and our output color will be our input color. There we go. Let's see. All right, it wants us to specify an array here, even though it's only holding one value, 1, 1, 1. Yeah. That is why it is always helpful to get your compilation information in here. Warning, truncation of vector type at line 55. Let's see, line 55. Here, okay. It's because we didn't specify which components of the vector we actually wanted to store. Implicit 37. I missed that, of course. Great stuff. Now we don't get any errors. As you can see, we load all our shaders and everything is fine and dandy. We haven't actually modified our vertex shader. I think perhaps this input is absolutely fine. Is that what we end up passing in the pipeline when we set it? Yeah, we actually only pass it position and color information, which is pretty fine, I think. I'm not sure we need to output the clip space. We just want to output the world position, meaning that basically I think you could, we still have to reassign the whole thing. We simply change the output to never start with the color and the position. We do the same thing for the color. And we do not need to load the pass data. This is our simple vertex shader for this pipeline. Let's see. Yeah, it's in the point billboard shader directory. So now we simply pass along our position and color information. We pass that on to the geometry shader, which is the new shader on the block. I almost wanted to say, but which takes our position in world space and our color for the specific point billboard that we're creating. It takes, or rather, creates an output of a place in homogeneous clip space and a local position. It creates a primitive ID and a color for that specific primitive. It uses our view projection matrix and our camera position. It starts by taking in the point that is the input and ends up assigning a primitive ID and creating a triangle stream. We create the coordinate system for this billboard. This makes sure that no matter where we create the billboard, or rather the square that represents a point in space, it will be oriented towards the camera, because the point in space is subtracted from the camera position, and that is creating our forward-going axis, and the last axis, the right direction, is computed from these two vectors, which are both normalized, like here. We subtract the up component and make sure that this is only a direction. In that space, we could change the basis vectors of this shader if we wanted to. Then we create the axis, or rather the vertices of the actual billboard, the four corners. As you can see, we only use the right and up vectors of this viewpoint, because there's no point in using the look direction, since the billboard should be placed in only 2D screen space of sorts. It should be oriented towards the camera, meaning that since we have that information up here in a specific coordinate system, for that coordinate system, right and up as vectors are the horizontal and vertical scaling of the actual billboard. So we create the four corners, we unroll them into a triangle stream where they the position in clip space gets translated by, or rather the world space positioning gets transformed into a homogeneous clip space by using our view projection matrix. We store the local position of each, or rather, this is could actually be called world position. I think it's less confusing. And we store our primitive ID and its color. Great stuff. So now we have our vertex shader, we have our geometry shader, we have some old stuff here that I don't need. Let me close a bit of this. Let's just see, we don't need that for now. All right. And let me see. The next thing is to do our actual pixel shader. And I just copied in the old pixel shader for the line segment pipeline. We will of course be inputting this instead. Let's see. We could. Yeah, since it's not texturized, I think that we simply just do like that. I'm pretty sure we don't need this information. But I do think it is required that we pass out the primitive ID. I don't think it's going to work otherwise. I don't think it's going to work otherwise. Yeah, I think this might even be it. Let's see. We definitely do have a crash. Error, users potentially. No, that's not an error. Well, we do not get an error code. Let's see. Ah, we do have some sort of compilation error here, I reckon. Let's see, pixel shader. Ah. Hmm. What are we doing wrong here? Let's see. Signatures between stages are incompatible. Oh, thank God for our DirectX debugging layer. Let me see. Uh, the input stage requires position. Let me see. Did I change something here? I might have. Is that the problem? Did I? No. This pipeline. SW position. Let's see if I disable this and simply just return the white color. It's been too long since I created. Let's see. Since I created shaders. So our output here. Rasterization unit is enabled. Pixel shader is not null. The stencil position is not provided by the last shader before the rasterization unit. All right. So we not? Is it because of our geometry shader? Yeah, I have to debug this because it crashes. Let's see. Inside the initialization topology point, so it is that system. Let's see. So it pertains to the actual pipeline here. Do I need to change some flags? I can't remember whether the flags here are different for a geometry-based rasterizer. Geometry a geometry shader. Pipeline. Let's see. Yeah, I have to Google it. Rasterize state geometry shader. Uh, DirectX12. I did this before, but usually I'm not sure whether. Let's see, geometry shader. Uh, I can't remember. Let's see. What does our debugging system tell us? We can also just Google the hello, welcome. I'm doing great. How about you? So our typical. Oh, that sucks, man. How come? Let me see the rasterize. Let's see. Yeah, so before the rasterizer is the geometry shader. So Apparently. Ah, just one of those days, huh? Um, it's all right. It's just DirectX12 debugging. I've implemented this before. I can't just can't remember which flags I have to change to be able to compile the pipeline. I think I started getting errors when I changed the pixel shader, right? This is the base shader, and this is. But yeah, DirectX is a bit confusing to say the least. Um, uh, once you go, all right. Um, but yeah, right. Oh, I see. What is? Let's see. I think this is, or isn't that the problem? No, it's not. Let me see, let me see, let me see. The problem is I'm getting trying to get this new pipeline to compile. If I simply disable it, everything works fine. But yeah, I'm trying to remember how to set up the shaders. Um, so our vertex output layer is going to create some information for the geometry shader to take in, or let's see. No, we're not. We don't need to pass in the position, I think. Not the semantic is the position, but our geometry shader does pass out the SV position, and the rasterization stage is the next one. So at least it does get should at least be getting the um, the appropriate information. Did I miss something in my arguments here? Uh, yeah, because you don't return anything when you step out. I'm from Denmark. How about you? And our error. I'm from Denmark. How about you? Let's see. Oh, how exciting. Are you doing programming or game development yourself? Yeah, nice. Are you working in Unity or what are you doing? Software too. Oh, nice. You're probably way better than me. Yeah? Wait a minute, wait a minute. Now I see the problem. All right, let's try something here. Uh, yeah, I like the Unreal Engine. I tried it myself as well. Let's see. So if we take one and bit shift it 4 spaces, we end up with 16. Let's see. Vertex shader, pixel shader, vertex shader, pixel shader. Great stuff. And then if we do not 16, but 1 and bit shift that 3 spaces, we get 8. Yeah, I think Egypt looks beautiful. So there's that. I've never been to Egypt. I would really like to go. Let's see, pixel, vertex. Yeah, okay, so this works. We're simply just checking if the flag is set. If the bit flag is set, we do like that, we do like that, we do like this. Here, so it's because it doesn't know what the output is. Geometry shader, shader bytecode, geometry shader, get blob, get buffer pointer, blah blah blah. That is why I simply forgot to set the actual actual information of the shader. No wonder it doesn't know what to do. There we go. Everything works. Great stuff. Uh, I've been coding for around maybe 1 year. Thank you. Yeah. How about you? C is major. I'm sure. I'm not sure what you mean. Oh, you mean computer science major? No, 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 no. I got. I have a. Ah, Oh, you mean yeah, yeah. No, I have a degree in something else. I have a what is kind of like a yeah, in terms of length of the degree. Sorry, the degree. It's kind of like an equivalent to a PhD in another field. I'm a clinical health specialist of sorts. So I work at a hospital. But in my spare time, I do coding. Oh, well, then we are in the same field. Seems like we. Oh, how are you liking it? That's awesome, man. You don't like it? No, I'm sorry to hear, man. That really sucks. I haven't created a Discord yet. I was supposed to do it, but I keep on forgetting. I might get get to it eventually. I probably should. I'll try to do it this weekend then. I'll leave a link in the on the YouTube channel and on the Twitch channel. All right. The pipeline is up and running. We could do some testing now. Uh, let's do a buffer. Boxes for debugging. Yeah, I'm on Twitch too. I prefer to use YouTube, but um, yeah, I'm also on Twitch. Um, all right, sounds awesome. I have some more people dropping by Twitch and chatting, and they're also doing a lot of game development. So sometimes we can get some nice discussions in the chat. So feel free to drop by, and I'll be sure to make the Discord channel as well. Let's do some points billboard. You too, man. Thanks for dropping by, and I hope the day gets better. All right, we're gonna set up the buffers. This is for the texture loading. It's not more really a test area anymore. Let's do point billboards. Maybe. I want this another place. Maybe I do not want it in the initialization method because I'm not sure that we want to be automatically creating these things if we ever decide to create a method where we kinda do a distribution build. So let's do something like renderer create point billboard buffers. Let's not, and let's add a scope to it. We do like this for now, and we of course do a bit of spacing, and then create buffers for debugging. And then we have methods for boxes. Methods for spheres. Methods for rays. Create coordinate system. All right, good stuff. I think we should do an unsigned integer buffer size. Whoops, my fingers are all over the keyboard here. And then we change the method here. All right, now we can create a buffer with this size. We simply initialize some dynamic buffers here. Let's just, excuse me, copy most of these methods. We're gonna disable this. We're gonna delete that. We don't need index buffers. Let's see. Okay. And we of course want to set up the and then did we, yeah, there it is. Oh, index buffer view there. That is completely wrong. So it's of course not a index buffer. Whoops. This is of course correct. This is the place. This is the debugging area. Debugging points, point billboards, and then for dynamic raycasting, debugging. There we go. We vertex line. Well, we can use the same data structure even though it's, yeah, okay. Let's just create another points billboard. Vertex point billboard times 0. Create it on an upload heap. We disable that last part. I think we simply create a number of points in our buffer. And we do our point vertex buffer point billboards. There we go. All right. Um, let's try to create a test point here that we simply draw to the screen. Temp, position equal to, yeah, in the center of the x-axis, maybe a bit far up on the y-axis, and then at the center on the z-axis, and then with the color of, yeah, let's do white. And we simply copy that in. Pass it as a reference, and then copy as much as needed. All right, let's just build this and look at NVIDIA Insight. Of course, we have to call the method. Debugging stuff. Is this on the on create? Yeah, it is. So we have our renderer. Let's create eight slots for buffer points. Great stuff. Let's do some work in terms of making sure that NVIDIA Insight can run. So we copy over the shaders to our Insight directory. And we do NVIDIA Insight graphics and do our project here. Let's see, inside our resources, we have our vertex buffer point billboards, but nothing gets copied over. That's not great. That's not great. Generic read. Heap type upload heap. Huh? I would think that it was supposed to create something on the oh, it's because I create stupid mistake. Also, this is going to need to change. There we go. Always read your code before you start wondering what is going wrong. Anyway, we should be able to see that our billboard point here got created. Let's just create a view that we can actually interpret. So with the position of 0.5.0, which is exactly what we specified, and the color of 11111, 111, 4 ones, if you're wondering, that also looks correct. All right, so now we have uploaded our data. The last thing we can do is during our render step here, we can actually do our points. Right now we have hard-coded the actual point, which is fine. Debug point billboards and debug points. All right, we have to change the excuse me, pipeline state. So we bind the pipeline state of the point. Let's see. We bind the pipeline state of the point billboards. We also have to set the yeah. So this gets I'm not sure we have to. Anyway, maybe we can skip that. Let's see. We actually want some of the same code, therefore I'm just gonna copy it. Let's try not setting the pass constant buffer. D3D primitive topology point list. Yeah, point list. Let's delete that. Okay, these draw calls are not helpful. We're back to setting our vertex buffers to our point buffer. Our index buffer is not needed. Let's see. Okay, it's the view to it instead. There we go. So this shouldn't do anything, but should compile and run without any errors. Let's see. Yeah, we're not getting any runtime errors down here, so that's great. Right now, we're just not doing anything. So we have bound our vertex buffer. We have bound our pipeline. Let's try seeing if we can make a draw call. Draw instanced vertex count 1, instance count 1, 0, 0. Let's try that. All right. Wow. We got our billboard. It's quite big. It's quite big. And we only got half of it. So let's see, vertex count. Maybe it's 4. I think it's 4. Nope, it's not. Maybe it's 2. Maybe I have a problem in our geometry shader. No, I think the problem is inside the geometry shader. So part of our algorithm here is correct. Let's see if we open our geometry shader. For one, we can half the size. Yeah. Let's see. 1, 2, 3. Am I doing this perhaps in the wrong winding order? Yeah, maybe I need to reorder this. Maybe we want this as the first one, this is the second one, because it's gonna use some of the vertices to wind the primitive. Yeah, there we go. It was simply because I ended up fucking up excuse me, I didn't say that. Ending up screwing up, that's not messing up the winding order. All right. So as you can see, everything is kind of working, or rather, it is working. We're creating a billboard that orients towards the camera. Great stuff. It's still somewhat big. I think maybe half of this would be fine. Maybe even half of that. Yeah, I think that is all right. Maybe just like that. Yeah, that's great. All right. So now we know that we can create Uh, let's see. We can create our buffer. We can create our buffer at initialization time. We could unsigned int m used points, which is going to be used point bb's, which is going to be something that we do here. And we simply stack up some draw calls. Let's see. Start vertex location. I. So right now everything shouldn't do anything. We can do a method where we, and then we want to set the m used points to 0 because we want to create them each frame by simply just uploading them. So we will use the whole of the start of the buffer for each first point. Right now we are able to create 8 points. We might want to create 16 points. That is probably better. Then we want a renderer method. Let's see, methods for points, and we do a add point bb gfloat 3 position, gfloat 4 color. Let's see. Doesn't contain any function signatures. No, that's a lie. No, that's a lie. Let's see. All right. Visual box. All right, we have them kind of all over the place. Let's just do that. Render raw. All right, if we ever want to add a point, we can use the kind of same method here, just with the and do we have to do pointer arithmetics here? Let's do a well, start pos equal to that. Our starting position of the pointer plus whatever offset we have. All right, let's do vertex pointer equal to reinterpret cast vertex point bb pointer start position. Let's just do like that. Start. Let's do start plus plus. And then simply do like that inside our render stuff. Let's see, we don't need to have that open. Our renderer here. Maybe we don't want to reset for now. Our application here. Let's do it once. mRenderer add point billboards. Let's just do the position of -2, 3, and 0. And then the color 1, 1, 1, 1. We set the position to the position and the color to the color. Yeah, does this work or does it crash? It should work. Right now, we shouldn't be writing to the start of the buffer, but instead to the second position in the buffer. If everything goes well. And we're probably not drawing anything for that exact reason. Let's see, let's arrange it in float 3, float 4. Yeah, everything gets stored in the second slot because of our pointer incremation here. So we can do our thingy here. Start plus equals that. Yeah, so right now it should draw. Yeah, it does. All right. That is great. Now, if we enable this again, we should get a reset. We should simply just see it for one frame. That's too fast to even realize. If we now move this part into the update loop, maybe this is the iterative solver, this blah blah blah. All right, player stuff. Let's delete that. It's not really player stuff. All right, for every frame we do that. Yeah. So now we can basically draw our contact points. We do I-list and contact data frame size, I++, and we do our contact data frame, I dot contact point, G float 3, position equals, now let's do math load float 3, no, store float 3, destination, position, and the source here. All right, and then gfloat 3 color, which will be like this color. The position will be our position. Let's see. Gfloat floor. There we go. So this should draw every contact point. Great stuff. Great stuff. The last thing we could wish for is our all right, great stuff. The last thing we want to do is be able to draw the contact normal. And we can do some raycasting where we pass in the start positioning. We want to calculate an end position. Let's do G vector scaled normal math scalar. Let's do contact frame I contact normal and do maybe 10. And then the G vector endpoint equals math add the contact point and the scaled normal, and then we do a gfloat3 end position where we store our end. Let's see, maybe we just do one register. There we go. And we do the end pos, and then we do like that. Okay, that's great. That's awesome. Great, great, great contact normals. Great stuff. Now, would you look at that? Isn't that beautiful? Anyway, I think they are too big. Let me disable that. I mean, does it really? Number of contacts. Four, two, one. Huh? No, it's just the way I did the debugging. And if we freeze this, And if we unfreeze it, I can unfreeze it right now. I can't. Okay. Let's not do the debugging ray right now. All right, I think that is an excellent point to be in terms of debugging the information from the physics system. Yeah, I'll be asking a couple of dudes on gamedev.net whether they can help me figure out how to adjust the algorithm. But yeah, we're done with this part of the algorithm. We have now the possibility of creating arrays like our contact normal and contact points and show them visually. And yeah, it's been some nice work. We also saw during this episode how to set up a geometry shader where we convert one point into a where we create one point into a series of vertices that ends up defining a rectangle, which we then draw to the screen with its appropriate color. I'm actually unsure whether these parameters are needed. All right, the position, the pixel position. Used as output, position of vertex. Okay. All right. Anyway, that is it for the part going on YouTube. I will segment off. If you find any of this helpful, useful, well, that's kind of the same, isn't it? And or inspirational, funny, whatever. Uh, Feel free to comment, like, or subscribe, or follow on Twitch. As promised during the stream, I'll be looking into creating a Discord channel as well. Thanks for dropping by, now or in the future. Hopefully I'll be seeing you around. And if you ever want to support my endeavors, feel free to support this channel. All right. Hopefully I'll be seeing you around.